So today we're going to look at Module 3, Lesson 6, which is when we're subtracting fractions from numbers that are between 1 and 2. So that means on the number line, they're bigger than 1 but less than 2. So you'll see fractions that are mixed numbers that look like this, 1 4/5, or you might see it written as a fraction greater than 1, like 9/5. Both of those are considered fractions that are bigger than 1 but less than 2. So it's a mixed number, which is what this is called, or a fraction greater than 1. And you treat them almost the same way. And we're going to be continuing to use rectangular fraction models when we're doing this math today. So if we look at number 1, they're asking that we draw rectangular fraction models for solving this. So let's first quickly look at A, because A is an interesting one. So it's 1 minus 5/6. So if I think about that, and I think about that rectangular fraction model for 1, I can call this 1, but I know that I can rewrite 1 in an infinite number of ways. I can write 1 as 1 over 1. I can write 1 as 2 over 2. Excuse me. I can write 1 as 3 over 3, 4 over 4, etc., etc., etc. So one way that I can write 1 is 6 over 6. 1, 2, 3, 4, 5. So if I have one whole and I split it into sixths, and then I'm going to take away 5/6, that means I'm going to take away 1, 2, 3, 4, 5. And I'm left with 1/6 as my remainder. So that's the beauty when you look at 1, is you can rewrite 1 in any infinite ways, and it makes the most sense to rewrite 1 in the way that makes the math the easiest. So let's look at B now. So it's 3/2 minus 5/6. So 3/2 is a fraction greater than 1. 3 is bigger than 2. It means I have 3 half pieces. So that means if this represents 2 halves, like that's 2 out of 2, I still need to draw one more rectangle to give myself one more half. So this is equal to 3 halves. So it's 3 half pieces. And from that 3 halves, I want to subtract 5/6. So just like before, I have my first number drawn out, and now I'm going to draw out my second number using horizontal lines. And I'm going to show 5/6. So this is 5/6. Now, every time we add and subtract fractions, we have to find that common denominator, so my pieces are the same size. And I have been paying attention to our past couple practices with this, and I'm starting to notice a pattern with finding common denominators. And for me, what I've noticed is that the common denominator is often the product of my two denominators. So right now I have a 2 and a 6. So I'm predicting that my common denominator is going to be 12. And let me show you why I think that. So if I take my 5/6 and I split it into halves, because I'm taking my first number, my 3 halves, and now I'm applying it to my second. So I'm splitting it into halves. My new fraction that I get is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 11, 12. 12. I get that 5/6 is equal to 10/12. All I did realistically when I split it in half is I times it by 2. So I times the 5 by 2 to get 10. This is a 10, not a 6. And I times my 6 by 2 to get 12. So far I'm on track and matching my common denominator prediction. Now my 3 halves I'm going to treat the same way, and I'm going to split into sixths. And the reason I'm splitting into sixths is because my other number is a denominator of 6. So I'm going to do 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So now, instead of 3 halves, what I have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my denominator is 12. but I have more than 12 pieces. I have 13, 14, 15, 16, 17, 18 pieces. So all I did was I times by 6 and I times by 6, which remember is the other number's denominator. So I think my prediction is right. And I kind of like using that prediction as like a check to make sure my drawings are correct, because sometimes my drawings can get a little messy and I miscount. So my new equation is 18/12 minus 10/12. So I can physically cross off 10 of these boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm left with 1, 2, 3, 4, 5, 6, 7, 8. And I can double check that math because I know my equation is 18/12 minus 10/12. So 18 minus 10 is 8, and then the 12 stays the same. Now, 8/12 can be simplified, and I know this because they have common factors. You might notice that 2 goes into both 8 and 12, so you can divide it by 2. But I also noticed that 4 goes into 8 and 12. So 8 divided by 4 is 2, and 12 divided by 4 is 3. So my final answer is 2/3, because whenever we're dealing with fractions, we always want to simplify it all the way down to its most basic form. So 2/3 is the simplified form because I can't divide it anymore. Let's keep practicing. So now I have a mixed number. I have 1 2/5 minus 3/4. So let's draw that out just like we've been doing before. So first let's do my 1 2/5. I know it's 2 boxes because I have a full 1 and I have my 2/5. And I'm actually going to box up my 1 as well. I'm going to make it into fifths because I want to make sure all my pieces are the same size, right? That we're all about finding equivalent fractions and common denominators, and we want our pieces to be the same size. So I'm going to split this 1 into fifths right now. And I know that it's really all of them because that full thing is full. And what I just created is I created 5/5. So I kind of have a 5/5 and I have a 2/5, which we could combine together if we wanted to and turn that into a 7/5 if we wanted to think about it like that. I also am going to do my subtraction piece now. So I'm going to do 3/4. So now I need to find my common denominator. I'm going to make my common denominator prediction, knowing that there is a 5 and a 4 as my denominators here. And I know 5 times 4 is 20. So I think 20 is going to be my new common denominator. But let's double check with the math and our models. So I'm going to take my fourths and I'm going to split it into fifths. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 20. And then I'm going to take my fifths and I'm going to break them into fourths. And now I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8. And then over here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20 20ths and I have 8 20ths, which makes sense with my common denominator check. And looking at that, 20 20ths and 8 20ths means I have 28 20ths in total if I wanted to think about it as a fraction greater than 1. Now that I have those pieces, I know I'm taking away 15 20ths from that 28 20ths. So I'm just going to cross off those pieces right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I took away 15 pieces. I cleared off this whole one and I had to go into the whole, which is fine because they're connected. And I'm going to see how many do I have left now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I should have 13 20ths as my leftovers here. Let's double check with the math. So I had my equation of 28 20ths minus 15 twentieths, because I'm thinking about them as their common denominators. And that does give me 13 twentieths, because 28 minus 15 is 13, and the 20 remains the same. So we drew our two models, we turned them into common denominators with equivalent size pieces, and then we were able to cross off and get to our 13 twentieths. Last one. Jackson had 1 3/8 kilograms of fertilizer. He used some to fertilize a flower bed, and he only had 2/3 kilograms left. How much fertilizer was used in the flower bed? So we know he had 1 3/8. This is what he started with. He used some for a flower bed. We don't know what that is. And then it said he had 2/3 left. And the question is, how much did he use in the flower bed? So if I'm going to draw this with a tape diagram, just to figure out what kind of math I'm going to do here, I'm going to start by my labeling. So I know he had, at the beginning, 1 3/8. He had a mystery amount in the flower bed, and then he had 2/3 left over. So I need to find that mystery amount, that question mark. What did he use in the flower bed? And from my tape diagram understanding, when I know the total and I know one of the pieces, I can find that mystery other piece using subtraction. So my subtraction should look like 1 3/8 minus 2/3. And then now that I know that, I can use my rectangular fraction models to find common denominators, and then I can do the subtraction. So let's find those common denominators. That's the whole purpose of our rectangular fraction models. I know I'm going to need 2 to represent 1 3/8. 1, 2, 3, 4, 5, 6, 7, and there's 3 of them. 3/8. I'm also going to split this into 8s. 1, 2, 3, 4, 5, 6, 7. To represent the whole 1. And I'm going to actually write that as 8/8. Because I know that's equal to the 1, and then I have 3/8. Now I'm going to subtract 2/3. Just like in other problems, I need to find that common denominator. I'm going to make the common denominator prediction because I have an 8 and a 3 that it should be 24, but let's just check with our modeling. So I'm going to split that 2/3 into 8s. 7. And by splitting it into 8s, I'm basically timesing by 8 and timesing by 8, which gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Because 2 times 8 is 16, right? I'm just using all this to double check myself. Out of 24, because it's 3 rows of 8. So 24, I'm right with my prediction. So 2/3 can be written as 16 24ths. And now I'm going to take my 8/8 and 3/8 and split them into thirds so I can find my equal pieces here. So I know it's out of 24. I know 8/8 becomes 24 24ths. Because anything, if it's equal to 1, it has to be the same numerator and denominator. And then my 3/8 just became 1, 2, 3, 4, 5, 6, 7, 8, 9 24ths because I times it by 3 and by 3. So now I have 24 24ths and 9 24ths, and I'm subtracting 16 24ths. So I can take this model and I can just start crossing off my 16 24ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I am left with 17 24ths. Let's quick look at how that would work numerically just to make sure. So if I have 24 24ths and 9 24ths in my separate pieces, that means all together 24 plus 9 is going to give me 33/24. That means in total, I had 33/24 at the beginning. And I'm doing 33/24 minus 16/24. That's the numerical equation that we just did. 33 minus 16 is my new step here. So let's see, 33 minus 16 is 17. So I get 17/24, which matches my picture answer. So that is awesome. Which means that my final answer here is that Jackson used 17/24 kilograms of fertilizer in the flower bed. That is my final. I have my number, I have my unit of kilogram because that tells me how much, and I have what it actually is, which is the fertilizer in the flower bed. So we were able to do some subtraction of numbers that are greater than 1, and we used our rectangular fraction models to find our common denominators, and that helped us do some subtraction here. So using the models and then double checking them with the equation is what I recommend doing. I also like the idea of predicting what you think the common denominator will be, right? And that's why I always write it in that top corner, because then I have that as my prediction and as my guide, as what I think the number should be. So then if I make some sort of mistake or if I'm counting wrong, I can keep checking it to use that as kind of like a guideline. So remember that when you're subtracting and you have a fraction greater than 1 or a mixed number, you do need to draw those two models. And then when you're subtracting, you might end up subtracting just from one of them, or you might need to use both. It kind of depends on the size of the number. But we can subtract fractions from numbers that are greater than 1 and less than 2, and really greater than 2 as well, because now we know the scale.